So dimensional analysis is the systematic approach to solving problems that we will be using throughout the semester, and in fact that scientists use throughout the world. And a simple example of dimensional analysis to introduce us to the methodology is converting one unit to another. And dimensional analysis always follows the same procedure as converting units. Okay? And the first step is to find an equivalence statement that will allow us to go from one step of our problem to the next. In the case of unit conversion, it will be the relationship between the starting units and the final units. And we are then going to take that equivalence statement and generate a conversion factor that will allow us to cancel units appropriately. So we are going to arrange our conversion factor to cancel the starting units and result in the units that we desire, our goal units. Okay, we are going to check in all cases that our units are canceling properly. We will then multiply or divide as appropriate, finally checking our significant figures, and always we want to do a little reality check and make sure that our answer makes sense. So let's do a couple of simple examples. So we can generate a length conversion between inches and centimeters, knowing that 1 inch is equal to 2.54 centimeters. So this is what we call our equivalence statement. Okay, and this is the way that an inch is defined in terms of metric units. So 1 inch is equal to exactly 2.54 centimeters. Now we can derive a conversion factor by either saying that there are 2.54 centimeters per 1 inch, or for every 1 inch there are 2.54 centimeters. And we will arrange it in one of these two ways depending on how we want to use this equivalence statement, and that is this conversion factor. So for example, if we are wanting to convert between centimeters and inches, so if we have 128 centimeters, we want to go to inches, we are going to arrange our conversion factor in such a way that our centimeters cancel and we are left with inches as our units. And so we will always follow this very straightforward process. So we will say 128 centimeters. It's important to always include our units here. And we're going to multiply this by our conversion factor. In this case, we want to go from centimeters to inches, so we want to make sure that inches are on the top, and we're going to use this conversion. So we'll say there is 1 inch per 2.54 centimeters. And then we will get our calculator, and we will say 128 centimeters. 2.54 is in the denominator here, so we will divide by 2.54, telling us that 128 centimeters is equal to 50.4 inches. 50.4 inches. So we are given 3 sig figs in our problem, so we will report 3 sig figs in our converted value. On the other hand, if we are converting from inches to centimeters, we will begin by writing the value in the appropriate units that we are wanting to convert. Now we're going from inches to centimeters, so inches goes in the denominator and centimeters goes in the numerator. So we have 2.54 centimeters per 1 inch. In both of these cases, we're making sure that our original units are canceling and we are ending up with the units that we desire. So in this case, we are going to, again, get our calculator out. And now we are going 128, but now the centimeters is in the numerator, and so we are multiplying by 2.54, telling us that's 325. Again, rounding to 3 sig figs. And so we will report this in centimeters as 325 centimeters. And this will be our final answer. So in both of these cases, we are going to include the proper units, and we're in the appropriate number of sig figs, 3 sig figs in both of these examples. And we're also going to want to do a reality check, right? We know that inches are larger than centimeters. So if we're going from centimeters to inches, our value should be smaller by about 2.5. Whereas if we're going from inches to centimeters, our new value should be larger. And so this should make sense to us. We shouldn't get a number like 50 down here and not a number like 300 up here. Now, in many cases, we will need to use these values for other calculations. And so here is another example of a dimensional analysis or unit conversion problem. So if we are trying to calculate the volume of a cube, we are going to multiply length times width times height. Since it is a cube, here measuring 16.4 inches, we can calculate the volume in milliliters, recognizing that 1 milliliter is equal to 1 cubic centimeter, and 1 inch is equal to, again, 2.54 centimeters. So to calculate the volume in milliliters of this cube, we are going to need to convert our inches into centimeters and then to multiply the length times width times height, or simply cube that value. So we are going to begin with what we are given, 16.4 inches. We are going to arrange our conversion factor such that inches cancel and we are given centimeters. So we will multiply this by 2.54 centimeters per 1 inch, noting that our units are canceling correctly. And then we are going to use our calculator here. 16.4, in this case multiplying times 2.54 tells us that this is 41.656. We will round that to 3 sig figs, so we will call this 41.7 centimeters. And now when we're multiplying this with our calculator, we are going to simply cube this value. So volume equals length times width times height. So we can multiply this number by itself 3 times, or we can simply raise this to, so we can multiply, where's my cube function? Let's go to this. So we are simply going to cube this value and round it to the appropriate number of sig figs. So we had 3 sig figs in the beginning. Again, we will round this off to 3 sig figs. So this will tell us this is 720 or 72,300 milliliters, or 7.23 times 10 to the 4th milliliters. Let's make sure we did that correctly.